Number 11 is a rational equation. All right, let's clear out the denominators. And to do that, we want to see what we should multiply by in order to get rid of those denominators. So let's factor the denominator, this one that can be factored. This is x minus 4x plus 4. So if we multiply both sides by x minus 4 times x plus 4, all three denominators will cancel. All right, so let's do that. So we're going to multiply the same expression on the left and the right. Okay, and then on the right-hand side, okay, this expression is the same as x squared minus 16, so those cancel. Now when we multiply x minus 4x plus 4 times the first fraction, the x minus 4's cancel, and we're left with x plus 4 times x. And now when we multiply x minus 4x plus 4 times the second fraction, the x plus 4's cancel, and we're left with x minus 4 times 4. And we have 8x on the right-hand side. Okay, so now we're going to get a quadratic, and we'll put that in standard form. All right, so let's multiply this out. We have x squared plus 4x minus 4x. And now we have minus, so that will be plus 4 times 4 plus 16 is equal to 8x. All right, let's put this in standard form. All right, notice here we have a 4x minus 4x, so those cancel. All right, and we'll subtract 8x from both sides, and we're going to end up with x squared minus 8x, these cancel, plus 16 equal to 0. Okay, so here this is this factors as x minus 4 times x minus 4. And check the middle term, minus 4x plus minus 4x is minus 8x. So we get one solution. Our one solution is x equal to 4, that same solution from both factors. And notice that this makes the denominator 0. Okay, so this is not a valid solution. We always have to check that if the solutions that we get make one of the denominators 0, which is the case here. So because our one solution is not valid, we have no solutions, or no solution over here. Okay, in question number 12, we have a cube root. And so what we're going to do is we're going to cube both sides. All right, if you want, we can write this as 3x minus 1 to the 1/3 is equal to 5. All right, and we'll solve that by raising both sides to the reciprocal of 1/3, or to the exponent 3. So we apply exponent 3 to both sides. All right, and so we just get here, we get 3x minus 1 is equal to 5 cubed, which is 125. All right, now add 1 to both sides, and 3x is equal to 126. And we'll divide by 3, and x is equal to 42. Okay, and we should check this. And we'll see that this does check. Here we have the cube root of 3 times 42 minus 1. Okay, and we want to know, is that equal to 5? All right, so that's the cube root of 3 times 42 is 126, minus 1 is 125. and the cube root of 125 is equal to 5. Question 13 is a radical equation. We have a square root in there, and what we do is we solve for the square root, and then we square both sides. So let's do that. We'll add the square root to both sides. So we have the x is equal to the square root of 6x plus 7. So basically we're isolating the square root on one side. All right, and then we're going to square both sides. Once we isolate the square root, squaring both sides will get rid of this square root. So here we have 6x plus 7 equal to x squared. And now this is a quadratic. Let's put it in standard form and see if it factors. So we have x squared minus 6x minus 7 equal to 0. And let's say this does factor. All right, this is x minus 7 plus 1. Let's just check the middle term. Minus 7x plus x is equal to minus 6x. So we get two possible solutions, x equals 7 and x equal minus 1. Whenever we square both sides, we must check our solutions. So let's do that. Let's do our check over here. So first we'll check x equals 7 into the original. So that would be 7 minus the square root of 6 times 7, that's 42, plus 7. And is that equal to 0? Okay, that's 7 minus the square root of 49, and that is equal to 0. All right, so this is x equals 7 is a valid solution. Let's check x equal minus 1. Let's check that solution. So here we have substituting in, we have minus 1, subtract 6 times minus 1, that's minus 6 plus 7. And is that equal to 0? All right, that's minus 1 minus, and here this is the square root of 1, which is 1, is minus 2. That is not equal to 0. All right, so this solution is not valid. So we have one valid solution. Question number 14 is another radical equation. This time the square root is isolated. Okay, here we already solved for the square root, so we just immediately square both sides. So right away we'll do that. We'll square both sides, the left and the right. So on the left we get 3y plus 1. And on the right we have y minus 1 times y minus 1. That's y squared. In the center we have minus 2y and plus 1. Okay, so let's put this is a quadratic. Let's put it in standard form. We'll subtract 3y from both sides, and that'll give us y squared minus 2y minus 3y. That's minus 5y. Subtract 1 from both sides. Okay, and these two 1's cancel. So we have 0 equal to y squared minus 5y. Now we can factor this by pulling out y. And so we get two possible solutions, y equals 0, y equals 5. We have to check those because we did square both sides. All right, so let's do our check. So first we'll check y equals 0. All right, let's substitute into the original. So that would give us 3 times 0 is 0, plus 1 we're substituting into here. So we have 1 equal to 0 minus 1. So that's 1 is not equal to minus 1. So y equals 0 is not a valid solution. All right, let's check y equals 5. And we have 3 times 5 is 15 plus 1 is 16. So the question is the square root of 16 equal to 5 minus 1? Well, yes, that's 4 is equal to 4. So y equals 5 is a valid solution. All right, so we have one valid solution. Question 18 is a quadratic-like equation. Here we have the square root of x, and x itself is the square root of x squared. So we have an expression, and we have the expression squared, and we have a constant. So that's why it's quadratic-like. So we're going to put y equal to the square root of x, and x is y squared. So this is y squared minus 3y plus 2 equal to 0. So this substitution gives us a quadratic equation. And then we'll solve this. We'll try factoring, and in fact, this does factor into y minus 2, y minus 1 equal to 0. Okay, check the middle term. We have a minus 2y and a minus y that's equal to minus 3y. Okay, so we have two solutions of this quadratic, y equal 2 and y equal 1. And let's put back the x. Y is equal to the square root of x, so that's square root of x equal 2, square root of x equal to 1. And square both sides, that gives us x equal 4. And here square both sides, and we have x equal 1. And now let's do a check. Okay, so first x equal 4 back into the original equation. So first we're trying x equal 4. So we have 4 minus 3 square root of 4 plus 2 equals 0. That's 4 minus 3 times 2 minus 6 plus 2 equals 0, and that's correct. All right, so x equal 4 is a valid solution. And now let's try x equal 1. Okay, so we have back into the original 1 minus 3 square root 1 plus 2 equals 0. Okay, and that's 3 minus 3 equal to 0, another valid solution. So we have two valid solutions. Okay, number 17, we have another expression raised to a fractional exponent. Okay, first we're going to solve for the expression raised to the fractional exponent. So we'll add 1 to both sides. So we're going to isolate 3x minus 1 to the 2/3 on one side of the equation. All right, so that's equal to 9 now. And again, like in the previous problem, we're going to raise both sides to the reciprocal of 2/3. So that would be 3/2. But now the denominator is even. So we're going to raise the right side to plus minus 3/2. Because it's the same as taking the plus minus square root of both sides. The 2 in the denominator is a square root. All right, so we have two separate equations. We have 3x minus 1. This is equal to 1. The product of these exponents is 1. So that leaves us with 3x minus 1 on the left equal to 9 to the 3/2. That's one equation. And we have 3x minus 1 equal to minus 9 to the 3/2. Okay, so 9 to the 3/2 is the square root of 9, which is 3, and cubed is 27. So here we have a 27. So 3x minus 1 equal to 27. And that's 3x equal to, add 1 to both sides, that's 28. And divide by 3, and we have x is equal to 28 over 3. And here we have 3x minus 1 equal to, again, 9 to the 3/2 is 27. So here we have minus 27. Okay, add 1 to both sides, and 3x is equal to minus 26. And x is equal to minus 26 over 3. Okay. And then we'll do our check. into the original equation. So first 28 over 3. So we have 3 times 28 over 3. That's just 28. So we have 28 minus 1 to the 2/3 minus 1 equal to 8. Okay, so that's 27 to the 2/3. 27 to the 2/3, that's the cube root of 27, is 3, squared is 9, and 9 minus, 9 minus 1 is equal to 8. All right, so this is a valid solution. 28 over 3 is a valid solution. Okay, let's check minus 26 over 3 into the original equation. Okay, 3 times minus 26 over 3, that would be minus 26. So we have minus 26 minus 1 to the 2/3 minus 1 equal to 8. That's minus 27 to the 2/3. And we have the cubed root of minus 27 is minus 3. Minus 3 squared is 9. So again, we have 9 minus 1 equal to 8. All right, so this is another valid solution. So we have 2 valid solutions. In number 16, we have 2x plus 1 to the 3/2 equal to 27. And we want to open these parentheses. So what we're going to do is raise both sides to the reciprocal of 3/2, that is to the 2/3. All right, so let's do that. So we have 2x plus 1 to the 3/2 equal to 27. And we're raising both sides to the reciprocal to the 2/3. Okay, now we multiply these exponents and the product is equal to 1. So that opens up the parentheses. Now we have 2x plus 1 to the 1. Now notice that since this denominator is odd, we did not have to take plus minus of both sides, the plus minus root. This is the cubed root, so we did not do plus minus. Okay, so here we have, on the right-hand side, we have 27 to the 2/3. 27 to the 1/3 is 3, and 3 squared is 9. Now, minus 1 from both sides gives us 2x equal to 8. And now divide by 2, and we have x equal to 4. Now let's do a check. So we're substituting in x equal 4 into the original equation. So we have 4 times 2 is 8, plus 1 is 9. All right, so that's 4 times 2 plus 1 to the 3/2. And we want to see, is that equal to 27? Okay, so we have 9 to the 3/2. Well, 9 to the 1/2 is 3, and 3 cubed is 27, so that checks. Okay, in question 15, we have another radical equation. One of the radicals is solved for, is isolated on the left side, so we're ready to square both sides. So let's do that. All right, so we're going to square both sides. On the left side, that square root pops off and we get 2y plus 9. Now we're going to FOIL the right-hand side. All right, so let me just write that out. Let's write out 2 plus the square root of y plus 1, just so we'll see the FOIL more clearly. Okay, so let's FOIL that out. So we have 2 times 2, that's 4. And then we have the middle term is 2 times the square root of y plus 1 plus 2 times the square root of y plus 1. So that's plus 4 times the square root of y plus 1. And the square root times the square root is just y plus 1. Okay, we still have a radical, so we're going to have to isolate that radical and square both sides again. All right, here 4 and 1 is 5. Let's subtract 5 from both sides. So we have 2y plus 9 minus 5, that's plus 4, equal to 4 times the square root of y plus 1, and we still have the plus y over here. Now subtract y from both sides. Okay, we want to isolate this radical. So we have minus y gives us a y here, or y plus 4 is equal to 4 times the square root of y plus 1. Now we're ready to square both sides. Okay, so on the left side we have, this is, let me just write this is y plus 4 times y plus 4. That's what we're doing here. All right, so so here we're going to get y squared plus middle term 4y plus 4y, 8y, plus 4 times 4 plus 16. Right hand side, here we have a 16 when we square, and we square this square root, and we get the square root sign pops off, and we get 16 times y plus 1. All right, let's simplify that. Y squared plus 8y plus 16 equal to 16y plus 16. So first of all, subtract 16 from both sides. And now set equal to 0 and factor, subtract 16y from both sides. So we get y squared minus 16y will give us a minus 8y here, equal to 0. All right, factor out the y. And there we have y equal to 0 and y equal 8. And we must check these solutions. Again, whenever you square both sides, you must check your solutions. So let's start. Let's do our check. Let's start with y equals 0. Into the original. Put y equal to 0 here. We have the square root of 9 on the left side. And here in the original, 2 plus the square root of 1. And that's 3 is equal to 3. So this is a valid solution, y equals 0. And then let's check y equal 8. We have 2 times y, that's 16, plus 9, that's the square root of 25. And is that equal to 2 plus the square root of 9? So it is, so we have 5 is equal to 2 plus 3. All right, so y equal 8 is another valid solution. So we have 2 valid solutions.